Hello friends, in this lecture we discuss construction of Turing machine that implement multiplication function. Okay, so we here implement a multiplication function by using Turing machine. Suppose we have a given this string over the input tape, okay, that is representing like this the m occurrence of 0, okay, and this is a separator symbol hash at the input tape, and we have an occurrence of 0. Okay, you can think this is a multiplicand and this is a multiplier. Okay, and this is also multiplier is also separated or by this hash symbol. Okay, and it is total string is surrounded by number of blank like this. Okay, and we have to implement a Turing machine that process this input instance into the form of m into n occurrence of 0 like this at the input tape, and which is also surrounded by number of blanks. This is our output. Okay, this is our output and this is our input. So we have to construct a Turing machine in such a way that takes this input and process into that. Okay, let us discuss this thing. Okay, how we do this. Okay, so here we assume our initial instantaneous description like this. Okay, so this is our form of initial instantaneous description, which is given in this form. Okay, and then this is the m occurrence of 0, and which is separated by a separate symbol, and this is a tape symbol, not input, and of course this is the n occurrence of 0, and after the computation, of course, we start with initial state q0 from this occurrence. Okay, this is representing this, this is same to this. Okay, so and this string is surrounded by number of blanks as discussed earlier, and we start with initial state from this situation, and after the computation we have to change ourselves or machine into this form. Okay, so this form telling us these blanks having the form this. Okay, like this. Okay, and we have this is the having the m into n occurrence of zeros, and of course this is our output, and which is also surrounded by number of blank. So we take the initial instantaneous description in this form, and after the computation we have to process our input string in this form. For this we have to construct a Turing machine. So let us discuss how we construct this Turing machine. Okay, for this we just understand how the processing is going on, and this is the logic for the construction of multiplication operation, and that convert this form of input into this form in a output form. Okay, so so we start with initial instantaneous description. As we discussed earlier, in initial situation we have the instance over the input tape in a Turing machine like this. Okay, this is the tape of our input tape, a Turing machine which is infinite in both the direction. Okay, and this is our input sequence. Okay, surrounded by number of blanks. Okay, so next look at this, the processing, how the processing is going on. Look at this, a very first 0 of our input string. Okay, this is our input string. The very first 0 is just processed and we replace into this blank. Okay, and we move further towards the multiplier side. Okay, so this is our multiplier. Okay, so this we copied after this separator symbol like this. So this 0 is copied in this form, and again this 0 is copied in this form. Okay, so like this. Okay, this is our 0. We clear it first for better visualization. Okay, so this 0 is converted into this 0 copied, and again this 0 is copied like this. Okay, so look again, this 0 is processed into after processing, means we're replacing this 0 by blank and move on right hand side towards multiplier. Okay, and we copy this multiplier in this form. So our multiplier is copied one times according to this. Okay, for the second time, okay, again for the second time, this 0. Okay, this is the second time. This is the m plus 1 time. Sorry, uh, for the complete, we have m, and in this situation m is what equals to 3. Okay, so for the first time we done this for m equals to 1. Okay, next for m equals to 2 we are doing this. So this 0 is again processed and replacing it by blank and move on right hand side direction. Again this is our multiplier which is copied in further this in this form. Okay, so this is like this. Okay, this 0 is copied like this, and again the second 0 is copied like this. Okay, so these zeros again copied after this partial multiplication. Okay, this is our partial multiplication at step 1. Okay, this is step 1, and this is a step second. Okay, and this is now our partial product. Okay, this is partial product. Okay, yes, for m equals to 3, this is m equals to 3. So this is m equals to 3, we process like this. Okay, like this. So again this 0 is, and this is for m equals to 3. For this 0 again processed into a blank format. Okay, blank means this is a process, and we move on right hand side direction. Okay, and this time again we copy this multiplier after, okay, to this partial product. This is our previous partial product which is come to the previous step second. Okay, now this we copy after this partial product like this. Okay, so this 0 is copied like this, and second 0 is copied like this. So this is our step third. I hope you understand the processing of copy of multiplication. So at this situation, at this step, you got the m into n occurrence of zeros. M into n occurrence of zeros. Okay, this is our m into n occurrence of zeros. Okay, so after this, the processing is not stopped. In continuation of this, we look like this. So this is achieved after step 3. Now we have to process these elements also, because after in the output we just required the m into n occurrence of 0. Okay, like this. So these things also be processed, means replaced by blank, and this is our final output. Okay, and we completing the process after reaching to this situation at final state qf. Okay, initially we started from this side. Okay, when it was 0, and of course all was 0, and we started with this situation with the initial state q0, and at this step in a final state qf. I hope you understand. Let us discuss this processing with the help of transaction function and transaction sequence. Okay, so initially we assume a transaction id, initial id in with this is our initial input. Okay, which is surrounded by blank, and we start with q0. Okay, and we assuming m equals to 3 and n equals to 2 in this case. Okay, so here when according to this initial id, okay, we expand this m after putting the value of m and n in this form. Okay, and of course in a transaction diagram we have this according to initial instantaneous description. Our initial state is q0. This is our assumption. Okay, so we know that this 0 is processed and changed into a blank and move on right hand side direction as the discussion previously in the logic. Okay, so this 0 is replaced by blank and move on right hand side direction and changing the state. Okay, so we write a transaction function like this. When we're reading 0 at q0 state, we just process it and overwrite it by blank and move on right hand side and change the state. Okay, so here we're changing our state q2. Okay, q1, sorry. Okay, so this is our state q1. Okay, please understand this is 1, not hash. Okay, please clear it. Correct it. Okay, so we reach to this instantaneous description. Okay, of course at this situation we just pass all these components, all these sequence, and reach to this multiplier. Okay, so after passing this 0, whenever we read 0 at q1, we just pass it. Okay, without changing these terms and move on right hand side direction. Okay, for this we write a transaction function like this. Okay, and we apply this transaction function at this sequence, then we may proceed like this after 2 times because for 2 0. Okay, I hope you understand this. Okay, when we reach to hash, okay, at state q1, then we changing our state because we mark that into a Turing machine that a further 0 is from from the multiplier, and for that multiplier we need to copy the multiplier. Okay, after this second hash. Okay, so here we when we reading hash at q1, we just change the state. Okay, so for that we have to write a one transaction function like this. Hash is just pass and move on right hand side direction and change the state q2. We apply this transaction function at this transaction sequence, and we get this. Okay, so at q2 we are reading 0. Earlier we read 0 at q1. When we read 0 at q0, then we just process that by replacing that 0 by blank and move on right hand side direction. Okay, and when we read 0 at state q2, it means this 0 is from the multiplier. Okay, and earlier it was from the multiplicand when we read the 0 at state q0. Okay, so this 0 at state q2 telling us that this is from multiplier, and for this multiplier we have a need to copy this multiplier after the hash symbol. So we just replace this 0 by x. Okay, and move on right hand side direction. Okay, and so like this we write a transaction function. For it we write a transaction function like this, and we read 0 at state q2. 0 at state q2, we just mark it by overwriting x and move on right hand side direction into a state q3. Okay, we apply this transaction function at this transaction sequence. Okay, so we get this thing at q3. We just pass this 0 and we move on right hand side direction until we read the blank. Okay, when we read blank, then we 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 just replace that blank by 0 for the copy. Okay, for the copy. Okay, so we move on right hand side direction. For that we have to write one another transaction function like this. when we read 0 uh, at state q3, then just pass that 0. When we read hash, then we just pass that hash and move on right hand side direction. When we apply these transaction function at this transaction sequence, then we after multiple transaction, this sign is representing multiple transaction, then we reach to this instantaneous description. Okay, so when we read blank at q3, it means now we have to copy corresponding to this 0. Okay, so we just replace this blank by 0 and take a left turn. Okay, for this we have to write one transaction function also. Okay, so we first write a transaction function that is like this. At q3, if we read blank, then we just overwrite it by 0 for the corresponding copy, and take a left turn and move on straight q4. When we apply this transaction function at this transaction sequence, then the next transaction sequence is like this. Okay, so this is what this blank is override by 0. Okay, and a we take a left turn. Okay, so this is left turn, so this is a hash, not a, this is, this to be correct, please. S is come in this situation. Okay, please correct it. Okay, so okay, I corrected. Okay, so after replacing this blank by 0, we take a left turn and changing the state according to this transaction function. Okay, so at this state q4, all the we moving on left hand side direction until we reach to this x. Okay, when we reach to this x, again we take a right turn and replace this 0 by x, and after reaching to the rightmost side, when we reading this blank, again we override this blank by 0. It means copy this 0 and take a left turn again. Okay, so in this way we are copy the multiplier after the second hash. Okay, second hash. So I hope you understand this. For this we have to write again a transaction function like this. At q4, whenever we read a hash, we just pass this and take a left turn. When we read 0, then we just pass it and take a left turn. We apply these transactions at this situation, because this is the corresponding situation, because we are reading hash at q4 and we're taking hash is replaced by hash and taking right left turn. Again we read 0, again we take a left turn and we come to this situation. So after applying these transaction function at this, after multiple transaction, we move to a next situation like this. After multiple transaction, we reach to this situation. Now here we are reading x at state q4. It means we reach to the multiplier again, and this x is telling the 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 left the left part of the means the first 0 is copied, and now for the second or more 0, again we follow the same process that is known as copy. Okay, so we take here in this situation right turn, and correspondingly for this 0 we make copy. Okay, so for this we have to write a transaction function also. So again, this is initial instantaneous description to this situation we reach. Okay, in according to the previous slide. Now we construct a transaction function. Okay, so when we read x at state q4, we just no change at x and take a right turn. Okay, so we apply this transaction function at this transaction sequence, and we move to this situation. Again, this is to the similar situation. Okay, previously we started from this, and we this process is known as for copied. We copied the 0 after this hash. Okay, so again we apply this procedure. Okay, and and so we, after multiple transaction, again we apply the same procedure, and after the multiple transaction we copied 0 corresponding to this 0. Okay, so we reach to this situation, and now this is the special situation when we are reading hash at state q2, this telling that the multiplier is copied. Okay, so again we have to backtrack and come to this for the into the into the m occurrence of 0, and process for the next occurrence of 0 same as the previous. Okay, so I hope you understand. So here we make one more transaction function like this. When we are at state q2 and we're reading hash, just pass this hash and take a left turn. Okay, and we apply this transaction function at this, and we come to the state q5. Okay, and left turn, and this hash is remain unchanged. Okay, and at when we read x at q5, then of course we know this is from the multiplier. Again we have to bring the origin, bring the multiplier in its original form. Okay, that is 0 0. So when we read x at state q5, then again we replace this x by 0 and taking left turn. Okay, for this we have to write a transaction function. So we write this transaction function, and this transaction function we applied at this situation. Then we come to the next situation like this. Okay, after multiplying after applying 2 times this step, this transaction function, because there are 2x. Okay, so again the multiplier is in the come into its previous form. Okay, and in the, again we're taking the left turn. This time we are reading hash at state q5, when we apply 2 times this transaction function. I hope you understand. Okay, so when we read hash at q5, again we have to remain unchanged this hash and move on left hand side until we reach to this blank. When we reach to this blank, again we take a right turn. Okay, so here student, we when we read hash at q5, we just change the state, and okay, for this we write a transaction function. When we read hash at state q5, then hash remain unchanged and take a left turn, and this time we change the state, because here we are reading the zeros, the remaining zeros of m occurrence of 0 in the input sequence. So we take a left turn and changing the state q6. When we apply this transaction function, we move to this situation. Again, if we reading a 0 at q6, this is telling us there is a remaining 0 in the m occurrence of 0 string. So the same process is need to be repeated again. If we read blank, okay, at this situation at state q6, then that is indicating the there is no remaining 0 in the m occurrence of 0 string. So the process is to be stopped, and we go for further acceptance or rejection sequence. Okay, acceptance is sequence. In this case there is no acceptance. This is because total computation. Okay, so let's see again. So for this, we again, when we read 0 at q6, we take a left turn and without changing this 0, and this time again we change the state. Okay, because we need to process this process again. Okay, therefore we change the state like this. In a Turing machine, we only change the state when the Turing machine want to remember something or want to store something into it. Okay, so I explained why here we change the state, because if we're reading 0 at q6, it means there are remaining zeros in the m occurrence of 0. Okay, as I explained. Okay, so we take a left and we apply this transaction function. Okay, at this transaction sequence, so we move to a next sequence like this. Okay, at this situation again, at q7, if we are reading 0, then just pass this 0 and take a left turn. Okay, and again, when we come to this situation, when we're reading blank at q7, then this blank is passed away. Okay, and take a right turn and changing the state from q0 like this. Okay, so this bring us back to a next 0 in the m occurrence of 0. Okay, so this whole process is repeat again. Okay, I think you understand this. Okay, so let's see what happening. Okay, so we come to this situation. This is the again. Okay, for this first 0 of m occurrence of 0, we copied. Okay, this multiplier. Again, for this 0, we copy to 0 again, and for remaining 0, we copy to 0 again. So this is the final steps. Okay, let's see. So we come to the next slide. Okay, in this after initial state, we are after multiple steps, after applying total process, we come to this situation. Okay, so let's discuss further to this transaction sequence. Okay, so after multiple transaction, student, after applying once again, we are in this situation. Okay, at this time, this second b, okay, this second b is replaced by blank, and we copy two more blanks after this partial product. Okay, I hope you understand. This completely process is repeat. Okay, now we again come to this situation. There is remaining one blank, so there it is repeat again. Okay, so again we are in this situation. Okay, but here we not applied all the transaction function. We just stop here because I want to explain why here we changing the state. Okay, so I telling you, when we reading a 0 at state q6, it means there is a remaining 0 in the m occurrence of 0. If we're reading blank at q6, means all the all the zeros of m occurrence of 0 is processed, and all copies of multiplier is have been done. Okay, so here we take a final decision. Okay, so when we reading blank at q6, and this is the new occurrence, which is new occurrence or new situation in this transaction sequence, and for this we don't have any transaction function in this Turing machine. Okay, so we just write a transaction function for it. Okay, and we write like this. Okay, so it brings out, okay, this computation and moves towards the acceptance side or a decision side. Okay, and for further processing side. Okay, because of course we know that these things should also be replaced by blanks. Okay, because we are in interest of this final result. Therefore we bring out from this situation and process further, like to to make all blanks. Okay, I hope you understand what I want to say. Okay, so here we take a outside computation. Okay, I hope you understand. Okay, so when we read blank at q6, it simply means that there is no remaining zeros in a m occurrence of 0, and we take a right turn and just just keep unchanged this blank. Okay, by using this transaction function. So we apply this transaction function at this transaction sequence, then we come to this situation like this. Okay, at this situation, now we know these things should be remaining, this things should be replaced by blanks also. So we write a transaction for it like an finite automata this hash is copied by blank and take a right turn. Okay, change a state, because we have to remember that a further zero need to be replaced again, and for this hash there is no need to further the further zero of this hash is not need to be replaced, because those are the answer. Okay, so these two hash are discriminant like this. Okay, so for this hash we change the state, uh, state that telling us this zero is need to be replaced by blank or override by blank. Therefore we here change the state. Okay, so we change the, we make a transaction function like this. Okay, and we apply this transaction function at this transaction sequence, then we move to this sequence. Okay, when we read 0 at q9, then of course we know this 0 is need to be override by blank. Okay, so by this for this transaction function, and at this transaction sequence again we move this, and once again we apply, and here we two time apply this transaction function, here we two time apply this at this situation at this sequence. Okay, so this is after two multiplication. Okay, I hope you understand. When we reading hash at q9, okay, earlier it was hash at q8. Okay, so we change the state, and but this time we change the state in a final state. Okay, okay, so for this we have to write a transaction function again like this, and we apply this transaction function at this transaction sequence that leads to a situation this. Of course this is our final transaction sequence. So let's done. We have completed from this situation. This is our initial instantaneous description, and after the multiple transaction we come to the situation this. Okay, where this is our output, and this is the m into n occurrence of zeros, m into n occurrence of zeros. I hope you understand. So this is the complete Turing machine for multiplying m occurrence of 0 and n occurrence of 0 and produce the output m into n occurrence of 0. I hope you understand this. Okay, so move further for the remaining part of this. Okay, so okay, so for this situation, now come to again, for this situation we don't have any further transaction and there is no need to make any transaction function, so we mark this as an halting situation. Okay, so this is halting situation, and qf is our final state, and so this halting at a final situation is known as a successful computation. Okay, so the tuple of this Turing machine is uh, this is the number of state from q0 to qf, and tau is a tape symbol 0 hash and blank. Okay, and b is a blank symbol, a by default symbol that is representing the absence of input. Okay, and your input is given in 0 and hash format. Okay, m occurrence of 0 is separated by hash. Further, an occurrence of 0 and hash. Okay, like this, and our q0 is initial state which we assume, and qf is our final state which we declared, and this is a transaction diagram. You can construct a transaction table from this transaction diagram also. Okay, thank you very much for watching this video, and for the reference KLP Mishra, Shudcam, Sipper, Peter Lynch, and you can mail at this for any doubt. And this was the construction of Turing machine without using a subroutine, okay, or interactive component. In a further lecture, we discuss the construction of a Turing machine for the multiplication operation with using subroutine.